Alright, section 13.1 talks about Laplace Transform, and this is the actual definition. So if you ever see on a test, verify by definition a certain function or use Laplace Transform, use the definition, that's the definition right there. This is what it says. If f of t is a function that's defined for t being bigger than or equal to 0, then the Laplace transform of this f is defined by f of s is the Laplace transform. It is L applied on the Laplace on this f of t, which is the integral from 0 to infinity of f of t times e to the negative st dt. So the whole work is on this function f of t, and that's the only thing that changes. Now, we're given a table. I'm going to show you the table. I'm going to post this in your Blackboard account or Canvas account, depending which class you're taking with me. And this table is provided. So what they did, they applied the Laplace transform right there. This is applying the Laplace transform. So instead of integrating, Laplace figured those out and put them in a table. Let me demonstrate. It says verify number 2. What's number 2? Well, number 2 is right there. Number 2 says f of t equals t. So number 2 from the table, we know that 2, again, it's right there, f of t equal t. So what does that mean? If I apply the Laplace transform on t, which is the integral from 0 to infinity of f of t times e to the negative st dt. That's it. My answer is going to be a function of s, and that's the Laplace transform. I go on the side and I say, alright, well, if we let u equal t, du is dt. And if I let dv equal e to the negative st, what's s? As far as t is concerned, it's a constant. If you integrate, v will be e to the negative st divided by negative s. So this is going to equal t. So that's going to give t times e to the negative st divided by negative s minus the integral of v du. That is e to the negative st over negative s dt. So that becomes a plus. That is t e to the negative st divided by negative s plus 1 over s. The integral of e to the negative st is e to the negative st over negative s. So this is going to be t e to the negative st divided by negative s minus 1 over s squared e to the negative st, evaluated from 0 to t and taking the limit st approaches infinity. So that is the limit st approaches infinity. Plug t in. You know what? I used t. I should have used a different letter. Let's use b, because t is already resolved. So plug them in. Again, remember this in terms of t. Plug this in for t. So that's going to be b e to the negative st divided by negative s minus 1 over s squared e to the negative s b. That's going to be the limit as v approaches infinity of, let's see how this works. So I know that e to the negative st minus, if you put a 0 in for t, well, if you put 0 right there, that's a 0. And if you put 0 in for t, that is 1 over s squared. That's the part I left out, because e to the 0 is 1. So this is going to be the limit as t approaches, b approaches infinity of here, the b over s e to the st minus 1 over s squared e to the sb plus 1 over s squared. Now, this will approach 0 and this will approach 0 as long as s is positive. So, if s is positive, I'm going to get 1 over s squared. And this is what we call f of s. And there it is. Now, guess what? You see number 2 right there? Laplace did the work and says, if you want to apply the Laplace on this t, the answer is 1 over s squared, which is right there. So on the test, if it says verify the Laplace transform by definition, you have to do that work. The rest of this chapter is pretty much just using that table. You really have to just mark what number you're using and it's all good. I want to verify property 4. What does that mean? Property 4 claims f of t equals, and it's in the table, for e to the at. E to the at. So, if I want to apply f of s, which is the Laplace applied on e to the at, is going to be the integral from 0 to infinity of e to the at, and the rest is the same, e to the negative st dt. So these parts don't change. These parts are the same for every problem. The only thing that will change is this part. Well, based on what I know about exponentials, wouldn't you say that this is the integral from 0 to infinity of e? I could say that's at minus st, so factor a t out. There we go. And that would be what? That would be e to the a minus st divided by a minus s, evaluated from 0 to b, taking the limit as b approaches infinity. That would equal the limit as b approaches infinity of e to the a minus s b over a minus s minus, if you put the 0 in for t, e to the 0 is 1 over a minus s. Now, the limit as b approaches infinity, this exponential will get to 0 if this is negative, if a minus s is less than 0, or if s is greater than a. And that would equal, let me just check really quick, as. That would equal negative 1 over a minus s. And if I distribute the negative n, that's 1 over s minus a, which is f of s. So, the Laplace applied on e to the at. If I want to use the table, it's right there. All what I have to say, put 4, circle it, and say it's 1 over s minus a. Instead of doing all of that work, there's the result. And I want to derive one more for you. I want to derive number 9 for n equal 4. Number 9. So if I want to derive number 9, so property 9, what's f of t? Property 9, where's 9? 9 is right there. T e to the an, t e to the an, t to the n e to the a t. Okay, I missed. T to the n e to the at. Well, but notice they said n equal 4 specifically. If n equal 4, that means 4 right there. Now keep in mind, they give us the answer right there. We'll talk about that in a minute. So what does that mean? If we say find the Laplace transform by definition, you apply the Laplace on t to the fourth e to the at, guess what? The integral from 0 to infinity, e to the negative st dt, that is the definition, and it's given right there. You don't have to memorize it. It's right there. The only thing that will change would be whatever this is right there. And how does that work? Integration. Well, let's see how this works. This is going to equal the integral 0 to infinity of t to the fourth e. Again, e to the a, so it's e to the at minus st. If I factor a t out, there it is. This is going to require integration by parts. I'm going to let u be t to the fourth, 4t cubed, 4 times 3, t squared, another derivative, 4 times 3 times 2t to the 1, 4 times 3 times 2, and a 0. And dv would be e to the a minus s. A minus s is a constant. When you integrate, you get that back, and you divide by a minus s. When you integrate again, you get e to the a minus s divided by a minus s squared. When you integrate again, and when you integrate again, remember the shortcut? So this is going to work to be this times this, and it's a plus. This times this, and it's a minus. This times this, and it's a plus. This times this, and it's a minus. So it's a big mess. That's going to equal, and let me write it out. It's going to be t to the fourth e to the a minus st divided by a minus s minus 4 times 3, 4 cubed, this one, 4t cubed, e to the a minus st divided by a minus s squared. I missed one. This one, plus 4 times 3t squared e to the a minus st divided by a minus s squared cubed. Okay, this is what I'm going to do. I'm going to shift this back. And I'm going to take this and put it right there. Hopefully that will fit. Plus this times this, so plus minus, that is 4 times 3 times 2t e to the a minus s t divided by a minus s to the fourth, and there should be one more, plus 4 times 3 times 2 times e to the a minus s to the t divided by a minus s to the fifth. And let me take this and shift that up. There we go. This is all evaluated from 0 to b, taking the limit as b approaches infinity. What a mess. And that's going to equal the limit as b approaches infinity. Now I'm going to plug b in, right? I'm going to take e to the a minus s t out, and I'm going to throw a b in there. So if I take it out of this, this, this. What's left? I have t to the fourth over a minus s minus 4t cubed over a minus s squared plus 4 times 3t squared over a minus s cubed plus 4 times 3 times 2t over a minus s to the fourth plus 4 times 3 times 2 times 1 over a minus s to the fifth minus, if I put a 0 in for t, that's a 0, that's a 0, that's a 0, that's a 0. The only piece left would be this piece, will be 4 times 3 times 2 e to the 0 divided by a minus s to the fifth. Now we know exponential dominates. This exponential will make all of those 0, provided this is negative, provided if a minus s is less than 0 or s is greater than a, then all of those will be 0. I would be left with negative 4 times 3 times 2, that's 4 factorial, over a minus s to the fifth. If I distribute the negative in, that is s minus a to the fifth. So this is all the work that we have to do. This is really what f of s is, by the way. Guess what? If you look at this right here on number 9, and if you look at that table, you say, look, t to the n equal 4, a is a. So n equal 4, that is 4 factorial over s minus a, 4 plus 1 is 5. That's 4 factorial over s minus a to the fifth. That's 4 factorial over s minus a to the fifth. And you could just say by 9 and you're done. And we're going to practice that right now. So for example, if I see this, use the table to find the Laplace transform. When I apply L operating on 3e to the 5t. Now if I look at the table, I notice the Laplace on a constant times a function. The constant you move up front. So I could say that is 3 times the Laplace operating on e to the 5t. That is 3 times what? And you're done. All what you have to do is use the table. Try to locate where e to the at is on the table. E to the at is number 4. E to the at, if you apply the Laplace, if you integrate from 0 to infinity, that's 1 over s minus a. So a is taking the place of 5, that's 1 over s minus 5. The only catch, you need to tell me that you used property 4. Otherwise, on a test, you will get no credit. You must show me how you're getting that. And if I wanted to do this problem, the Laplace applied on t to the fourth e to the at plus 3 the sine of 2t. So I could integrate, that will take a long time. Or I could say, look at the table, it says if you are taking the Laplace of two things added, you could add or subtract. So this is going to be t to the fourth e to the at plus 3 the Laplace operating on the sine of 2t. Well, t to the fourth at, we did. It's right there. But I don't want to really integrate. I'm able to use the table. So if I look at the table for t times an exponential, t times an exponential is right there, number 9. It says t to the n e to the at is n factorial over s minus a to the n. So t to the 4 is taking the place of n. That is n factorial, 4 factorial over s minus a to the 1 more than n. 1 more than 4 is 5. Now all what you have to do, instead of doing all of this work, you could jump straight to the answer and just tell me, well, what did you use? You used 9? Oops, sorry. You use 9 on top of that, and you know exactly what happened. And how about a sign? Do you see a sign in there? Sign. Right there, number 5. Sine of AT is A, the number in front of t. A divided by S squared plus A squared. So it is, A is taking the place of 2. It is A, which is 2 over S squared plus A squared. But A is 2. 2 squared is 4. And this is by, what allows me to say that? Number 5. And on top of that, you would write a 5. And me and you are very happy. So you must show me how are you getting those. You can't just give me the answer. And if I go by part C, I have an exponential times, by the way, that's f of s, and that is f of s. Now, an exponential, the Laplace applied on 2e to the 4t, the cosine of 3t. This is the constant I could drag up front if it's multiplied. I need to figure out where do we have an exponential times a cosine. An exponential times a cosine, number 8. The exponential, so if the power of the exponential is a, that's s minus a squared. That is s minus a is a 4 over s minus 4 squared. Now 3 is taking the place of b. If I look at the cosine of b, that is plus b squared plus, what's taking the place of b? 3. 3 squared is 9. You're done. All what you have to do is tell me what did you use to get that. You have to tell me clearly what did you use. We used the cosine, we could use number 8, so if that's the only thing you use, you have to tell me by 8. You could put that on top of the equal, that works perfect. And you're done with that part. And there's one more to go. How about if I had a t multiplied by a sine? So the Laplace applied on 5 the t, the sine of 40. Again, this will be very long if I'm going to integrate. This will be very long if I'm going to integrate. So after we do the first part of the homework, we will appreciate how quick this is. What Laplace did, he integrated all of these functions and have us just use the table instead. And that is 5 times, and that's my f of s. And what is that? T times a sine. T times a sine, I don't see any right there. T times a sine. T times a sine, right there, 13. T times a sine. 2as. A is the argument, the angle. 2as. What's taking the place of a? 4. So it's 2 times 4s divided by 4 is taking the place of a. S squared plus a squared, quantity squared. S squared plus a squared, quantity. You could make that an 8, of course. So you could say that is 5 times, that's 40. S over s squared plus 16 squared. And if you're not sure how to do this, you can integrate and get the same thing. And that's pretty much it for this section.